Have you ever really stopped to think about the metal objects all around us? You know, the body of your car, the frame of your computer? How do they go from just a flat, kind of boring sheet of metal into these complex things we use every day? Well, today we're going to take a journey to uncover exactly that, the fascinating process of sheet metal fabrication. So, let's get into it.
So let's start with a question. What do these three things, a car door, a kitchen sink, and a computer case, really have in common? I mean, they seem totally unrelated, right? But believe it or not, they all share the exact same origin story. They're all products of a single fundamental process that honestly invisibly shapes the world we live in.
And the answer, of course, is sheet metal fabrication. At its very core, it's really just the process of taking a simple, flat sheet of metal and turning it into something useful and three-dimensional. It's really a journey from 2 dimensions into 3. So, first things first, let's just take a second to appreciate how unbelievably widespread this process is. It's like the invisible backbone of our modern world. And I promise, once you start looking for it, you are going to see it absolutely everywhere. I mean, just look at this list. The sheer variety is mind-blowing. We're not just talking about heavy industry stuff. This process is essential for everything from aerospace and construction all the way down to the refrigerator in your kitchen and, yeah, probably the case of the very device you're watching this on right now.
Okay, but how does a complex car door actually come from a simple sheet? Well, like any great product, it all starts with a super detailed plan and, just as importantly, choosing the perfect foundation, the metal itself.
You know, before a single piece of metal ever gets cut, there's this incredibly detailed digital planning phase. It all begins with the design, right? That's done in what's called CAD, or computer-aided design software. From there, engineers figure out what tools they need, they calculate all the costs, and they work together to iron out any potential problems way ahead of time. It's only after all of that is done that they finally choose the material. This whole digital step is absolutely crucial because it catches mistakes before they become expensive, real-world problems. And this is where our journey really begins, with the raw material itself. We're talking about a flat, thin, bendable sheet. And if you want to get specific, the industry standard defines sheet metal as anything thinner than 3/16 of an inch for steel or 1/4 inch for aluminum. This is basically our blank canvas. Now, the two heavyweights in the fabrication world are definitely steel and aluminum, and picking between them is a classic trade-off. Do you need something that is incredibly strong, super durable, and won't break the bank? Then you're going to go with steel. But if you need something lightweight, something that won't rust, and something that's easy to form into really complex shapes, think airplane parts or car bodies, then aluminum is your champion, hands down. And of course, it's not just a 2-horse race here. You've got other key players. Stainless steel gives you that awesome rust resistance and that beautiful finish, which is perfect for kitchen appliances. Copper is a huge deal for its ability to conduct electricity and its antimicrobial properties. And then there's brass, which has that unique gold color for decorative stuff or architectural pieces. The choice of material is always tailored to what the final product needs to do. Okay, so our plan is locked in, our material is selected. Now we get to the really dynamic part of the process. This is where we take that flat sheet and actually start giving it shape and dimension through a whole series of super precise cuts and bends.
And listen, there isn't just one way to cut metal. It's all about picking the right tool for the job. For fast, simple, straight cuts on a massive scale, use a giant process called shearing. For really intricate, complex designs, a high-powered laser gives you incredible precision. Need to slice through some seriously thick steel? A plasma cutter is your best friend. And for materials that can't handle any heat, a high-pressure water jet can cut through almost anything without warping it at all. It's pretty amazing. So, once the pieces are all cut out to the right shape, they need to be bent. And honestly, the best way to think about this part of the process is as industrial-scale origami. It's all about creating precise folds and angles to build a 3D structure from a flat 2D plane. And to create those folds, there are a few key techniques. V-bending is kind of the workhorse here. It uses a punch and a die to create really sharp angles. If you need smooth curves or cylinders, the metal gets fed through these powerful rollers. And for making thousands of identical parts, stamping presses can form complex shapes in just minutes. It's all about high-volume production.
All right, we've got our shaped pieces. Now it's time to bring them all together into a final product and then apply those critical finishing touches that protect it and give it that polished, ready-for-the-world look. So how do you connect all these different parts? Well, it really depends on what you need. For a permanent, super strong bond, welding is the go-to. You're literally melting the metal pieces into one. Riveting is a fantastic mechanical option that doesn't require any heat, which is a big plus. And, of course, if the product ever needs to be taken apart for maintenance or repair, simple fasteners like bolts and screws are the obvious and logical choice. And here's a really key piece of wisdom from the design world. Smart fabrication isn't just about making cool, complex parts. It's about making the assembly as simple and foolproof as possible. By designing products with fewer individual components, you automatically reduce the chances for error, you speed up the whole process, and at the end of the day, you save a lot of money.
A raw metal product, well, it's not going to last very long out in the elements. So the final step is finishing, and this is for both protection and for looks. Powder coating gives you a really durable, colorful shield. Anodizing creates an incredibly hard protective layer on aluminum. And galvanizing coats steel in a layer of zinc to stop it from rusting, which makes it absolutely perfect for anything that's going to live outdoors. Okay, so we've seen the entire journey now, from a digital plan all the way to a finished product. So let's just zoom out for a second to the big picture. What is it that makes this process so completely essential to all of modern manufacturing?
The advantages really are crystal clear. I mean, it's cost-effective, it's incredibly precise thanks to computers, and it has this amazing strength-to-weight ratio. Then you add in its sheer versatility, plus the fact that it's sustainable and super fast, and yeah, you can really see why sheet metal fabrication is a true cornerstone of how we make things today. So, I'll leave you with one final question to think about. Now that you've seen the entire journey, from that simple flat sheet all the way to a finished product, I want you to take a look around you, right now. Which object in your world will you never, ever see the same way again?